Yeah, we're here.
Well, we are ready. Hello, everybody. Welcome to another edition of Address Space Layout Randomization. As always, I'm joined by Serena and Ryan. I guess Jason couldn't be here because he was being chased by a bear or something. I don't know. It's weird. I
No,
don't know.
he's back from that trip. He's back.
But the bear followed him.
Yeah, the bear
Oh,
tracked him
So,
down.
okay. That
so
explains it.
And I'm here with the dramatic lighting simply because I am down at the Hacker House for Black Hills Information Security down in Costa Rica, trying to do vacation, I guess, is what I'm up to right now. So just want to say thanks so much for joining us this afternoon. And we are going to be working with a tool that I absolutely love called John the Ripper. But before we start talking about John the Ripper, I don't think we have screen sharing. I would like to talk a little bit about Hashcat.
You
A
you want the
number of
spreadsheet
you,
thing that you got here?
perfect. Let's go ahead and share that out real
All
quick.
right.
So a lot of people, Serena, we talked about password cracking, and you'd mentioned that you'd used John the Ripper. I think that there's a lot of people, and correct me if I'm wrong or if this is your opinion, but a lot of people get really hung up on the best tool. Like, this is the best tool, and then you don't use any other tools.
Yeah.
And Hashcat, I would say objectively, is like the best tool for password cracking for most situations, right?
Yeah, I mean, I just use whatever is in my up arrow. So whatever's the most recent there is what's gonna work.
It's just like, what's in my history? Oh,
Yeah.
that tool.
All right. We'll go with
Well,
that.
and it's funny, like these videos and YouTube videos are kind of the equivalent of the up arrow for me because I'm literally keeping a running record of things. Like everyone's like, well, he must know way more than what he does in videos. No, this is it. This is my memory because the 80s and 90s burnt out my brain as much as possible. But with Hashcat, talking a little bit about Hashcat, how Hashcat works, and I want to talk about it specifically in the context of capture the flag events. So whenever you're looking at a capture the flag event, if you believe that you need some kind of like super turbocharged password cracking rig for the CTF, unless it's explicit, it's a Hashcat type lab, you're probably overthinking it and you're probably overworking the issue. And let me explain why. Whenever you're creating passwords for classes or capture the flag events, you can set up two types of passwords, and there's nothing in between. Either A, you set up a password that cracks almost instantaneously, or B, you set up a password that's going to take like an hour or two to crack. And that has a lot to do with the nature of the types of cracking that password crackers go through. Generally, most password crackers will go through a straight combination or just a word list, where it's going to go through a dictionary. Then they'll move into a hybrid word list where they do word mangling, where they take a word like password 123 and they'll replace the A with an ampersand, the S with a dollar sign, and all of those different things. That's usually in John the Ripper. That's cracking form 2 in Hashcat. It's basically their hybrid word list. And then the third option for password cracking is straight up brute forcing. And that's where you're going to try all the different permutations that exist for passwords. And a lot of people, whenever they think about that, they think about it incorrectly. They think it'll start with like A, B, A, C, A, D. And the really good password cracking tools out there for years have done something called key weighting. And key weighting is basically where they know that certain key combinations like TH will be used more than others. And it'll give that preferential treatment. So there's a lot to it, right? If we're talking about password cracking. But if you're trying to do a capture the flag event, right, and you're trying to crack passwords, Hashcat is awesome, but you may run into issues with virtualization and not having a GPU because Hashcat rocks in utilizing a GPU. You can try to get OpenCL drivers for your virtual machine, but still you're not going to be taking advantage of that full GPU cracking. Or you have a dedicated GPU cracker back at the office or somewhere in the cloud, and you can do that, and that gets really expensive. Now, all of that being said, okay, whenever you're cracking passwords for CTF or for like lightweight password cracking, you probably don't need Hashcat. You probably don't need a GPU. You can probably do just fine with John the Ripper. So in this particular session, it's basically, you got to learn to love John the Ripper and what it can still do for you, and not play the game of, well, that's old, Hashcat's new. Your specific goal and objective is more important than the tool that you actually utilize, and getting comfortable with a great number of tools is also really, really important. So I'm going to show you two kind of weird, obscure kind of ways that you can use John the Ripper, just to kind of highlight some of the power associated with John the Ripper, and some of the things you tend to see in CTFs. And I'm going to solve one of the CTF challenges in Meta CTF as part of this video. So I'm going to go ahead and I'm going to jump over. Let's go ahead and get started with the VM that I'm using on the 15th. So I am going to be teaching a class, Intro to Security, on August 15th. And I've done this a number of times where I like to show some of the labs and some of the things that we're doing inside of this virtual machine, just because it's really, really super cool to get you an idea of what we do at Antisyphon. And by the way, this training is pay what you can. If you go to Antisyphon Training and then go to live classes, just go to the calendar and then look for my name. All right, so let's go ahead and let's get started. I'm going to close a lot of these out right here. Okay. And these are the labs that exist in the Pay What You Can Intro to Security class. We cover, Linux command line, Intro to SOC is Intro to Linux command line, memory analysis. I'm going to zoom in a little bit just to make it easier for the old people to see. So these are the labs that exist. Linux command line, we have TCP dump, Windows command line, Windows log review, web log review, Deep Blue CLI, Nessus, Velociraptor, LCLAB as well. So a bunch of cool things for Intro to SOC. But the lab that we're doing today is under Intro to Security. And this is what I'm going to be teaching next week. And for that class, we have App Blocker, BlueSpawn, Deep Blue CLI, Nessus, Nmap, password cracking, password spraying, responder, Rita, Sysmon, and web testing. So a lot in 2 days. There's a lot of hands-on in 2 days of classes spread over 4. But the lab that we're going to be looking at is we're going to be looking at Responder, and we're going to specifically look at it through the lens of cracking NTLM v1/v2 password hashes. So let's get started. So whenever we're talking about Responder, Responder is a tool that was created specifically to attack 3 different types of protocols. Link local multicast name resolution, and NetBIOS name services, and MDNS. And the way that these different protocols work is a system can put out a broadcast request to resolve a name for a system. And then any system on that local network segment can respond back with 0 authentication, and it's absolutely trusted as the correct answer. So what we're going to do is we're going to set up Responder. We're going to trick the Windows system to authenticate. Then we're going to intercept that password hash for that authentication. And then we're going to crack that password hash for that authentication utilizing John the Ripper. So I'm going to open up my Windows terminal because we're going to need to run Windows subsystem for Linux. And this is all in the VM. In fact, you can even download this VM and you can get access to these labs without even taking the class. If you just Google John Strand, Antisyphon class VM, full instructions to set all of this up at home. You don't need to pay to take the class. We aren't setting it up where, the only way you can do this cool stuff is if you give me money. That's not quite what we're doing here, right? So if we're following the instructions in the VM, the first thing that we've got to do is we've got to set up Responder, right? For that, we're going to do a drop-down in Windows Terminal. I'm going to choose Ubuntu 18.04. I'm going to become root. Password is ADHD. And I'm going to cd into opt responder. Now we're in the directory. Now, for Responder to work, it's one of the easiest assessment tools to get running, and it's just super effective at what it does. So let's go ahead and let's get started with it. So all you need to do is do responder.py, specify an interface with a capital I, and then give it an interface. I'm going to give it eth0. All right. So now Responder is running. Now, in the background, what Responder is looking for is any type of authentication for link local multicast name resolution, not authentication, but resolution request for link local multicast name resolution, NetBIOS name service, DNS, MDNS. But then look at this. These are the servers that it stands up. So somebody may try to authenticate to a web server or a WPAD server, SMB server, Kerberos, SQL server, FTP, IMAP, and it's going to stand up these fake services whose sole purpose in life is to intercept authentication. All right, that's all it's actually looking for. And you can already see right out of the bat with MDNS, we can see it's trying to get it. So let's give it something to chew on, right? So I'm going to open up File Explorer, and I'm going to mimic kind of what we see if somebody is trying to authenticate to a server that no longer exists there. So down here at the bottom, you can see that my Windows computer system tried to authenticate, no! And the responder system saw that request for authentication and sent a poisoned answer to this desktop and this user. And specifically, it intercepted the NTLM-v1 authentication, and it actually intercepted the NTLM-v1 password hash. Now, let's talk a little bit about what these hashes actually mean. On a Windows computer system, there's only two types of hashes that are stored. The first type of hash is a landman hash, which is predominantly deprecated, but it is in fact still stored. If you look at a landman password hash, most Windows systems today will start out with AADB3, which is the hash of padding. Okay, and what that hash of padding actually represents is it's using a blank password hash to encrypt. It's going to use it as a key to des-encrypt KGS exclamation point at symbol pound prompt $sign. All right, and that's what it's going to do, but it's blank because by default Windows doesn't store the landman password like at all anymore because it's incredibly easy to crack. The other password hash that it utilizes is something called NT, and NT is a straight MD4 hash of the password, which is great. What we intercepted here is what we call the net NTLM v1 password hash, which is actually the NT password hash. Actually, that's not true. So if you look at Landman, Landman is an authentication mechanism where it has a challenge and a response associated with it. NTLM v1 replaces the Landman hash with the NT hash. And net NTLM v2 does NT, and it has time-based and all kinds of other things baked into it. So it's a lot more complicated. So if you're looking at authentication protocols, if you want to just kind of keep this clean in your head, Landman authentication and NTLM v1, same thing, except with Landman, it uses the Landman hash. With NTLM v1, it uses the NT hash. So it's the same algorithm in the background. Once you move into net NTLM v2, it gets a little bit weirder with a whole bunch of other fields in there. Yeah, Serena, question.
So Extreme Paperclip asked if SMB signing is on and required, does that make responders' job more difficult? Also, hi, John.
It can if it doesn't allow for a downgrade. And I think, Serena, once we get our environment up and running, I think one of the first things we should do is like NTLM Relay X to kind of show like SMB signing and those types of things. But yeah, if you can get that downgrade, you can enable SMB signing, but you got to enforce it for all communication across the board is really what you need to do. Mm-hmm. Good question. All right. So with this, we captured the NTLM v1 password hash. So now if we were going to capture the flag, what I would do is I would have a system on the same network as the contestants that would basically be shooting out would be shooting out LLMNR and NetBIOS name service requests so that the contestants would have to trick it and then get this password hash off of the network. So yes, you do see this in CTFs. So what I'm going to do is let's actually go through and crack it. Right? So I'm going to go ahead, kill that, scroll up here. Now I'm going to CD into logs. Oops, not that. Let's go CD into logs.
Wait, is John frozen? Am I frozen?
I think John froze because I was wondering the same thing. What happened? Did I just I disconnect myself?
John's really building up the suspense.
Oh, turn my light off. The suspense is thrilling. I don't know what he was doing, so I can't help out here. Oh, he disappeared. I guess he just lost the internet. Maybe we'll give him some time here. Let's give him like 30 seconds, maybe.
Don't leave us, everybody. Instead, I will tell you a story in the meantime.
There we go.
So I don't know if anybody here watches The Bachelorette, but there is this thing that happened on it that really is bothering me. But this guy went on The Bachelorette, which is supposed to be like 6 weeks long, right? And it's bothering me so much. His dog has like little doggy cancer and doesn't have that much time to live. So he's like telling this story about this girl to this girl, being like, oh, like my dog, I love him so much. And then he shows that he brought the dog's like favorite duck toy. And I was like, you stole the dog's favorite toy to bring on The Bachelor with you, so your dog is at home sick and now doesn't have its favorite duck. I mean, I think that's weird, right? Like,
yeah.
Right. I think it's weird that he would do that.
We have John trying to come back.
White cyber duck's like duck.
Yes.
So he used his dying dog. Yes, he did use his dying dog as a social engineering tool, but he's so bad at it that he didn't even think it through, and he brought the dog's duck. And not only this duck, he cut off one of its like little flippers. I don't know.
Well, welcome back, John. Welcome to Duck Stories.
Yeah, Duck Stories. So don't let me interrupt.
I had to improvise.
Yeah, let's improvise. It's like, oh, we lost something on Responder and Net NTLM V1 versus 2. Ducks!
No, it's just something that had been bothering me since last night. I wanted to get everyone else's opinion on it.
So did we get there, or do you want me to continue, or do we still have to get to the big question on ducks?
No, we got to it. I think Ryan says that it was weird that he did that. I don't know if you got any of the story at all, but this guy on The Bachelorette stole his dog's favorite duck and brought it on the show while his dog was at home dying.
Yeah.
Isn't that weird?
That is weird.
It's so weird. Anyway, all right.
Because if there was 2 ducks, it would be a paradox.
Yeah, maybe he had a second like decoy duck. I don't know.
Of course, this has to happen like right when I'm doing this. I think tomorrow we're going to set me up on the UPS and have a backup ready to go right there. So, all right. So we were getting ready to crack some passwords. So let's go ahead and let's do that thing where we're going to crack passwords. I need to pull this back down. Sorry. So again, sorry everybody. It's a thunderstorm, so that's what.
Oh, is it really?
Yeah, it's like so rainy and stuff today right now. It's pretty crazy. All right. So what we're going to do now is we're going to share a screen, and we'll go back to my VM, and we're right back to where we left off. All right, Ryan. There we go. All right.
There it is.
So now what we're going to do is we're going to actually crack the password hash for this. And you will get an update on your Windows system where it's going to be like, cannot find the shared, check the spelling again. It doesn't matter. I've got the hashes, so we're good to go there. So next what we're going to do, since we're in the log directory, and we're going to go through and we're going to crack the passwords associated with that. But I want to show you a little bit on formats. So with this, let's go ahead and just copy that. We're going to go ahead and run John the Ripper, but the way that we're going to do it first is we're going to do John the Ripper show. Let me zoom in again. Show equals formats. There we go. Oh, I got that wrong. Let's go John the Ripper. It's list, isn't it? I always get that command wrong. So let's go -- list equals formats. There we go. These are all the formats that John the Ripper can crack. Okay. And that's actually pretty extensive. I would actually put its formats on par with like Hashcat, because there's a lot of them, especially when you're dealing with a lot of legacy-based protocols. But for this, the format that we're going to be cracking is not NTLM v2. We're going to be cracking NetNTLM, because that's what it actually captured. And now we're going to feed it in the actual. We're going to actually feed it in the actual hash. So there we go. NetNTLM v1, like that. And then we have our, scroll up here so it's easier to see the command. Then we have the file of the hashes that it actually intercepted. So we're running John the Ripper. And by the way, this is John the Ripper with the jumbo patch. Okay, so this is John the Ripper with the jumbo patch. And we're going to crack the landmines. And there it is. So I was able to quickly identify the user ID of ADHD and the password of ADHD. Now, once again, this is like a very, very quick and stupid, easy password to crack. But once again, if you're in like a capture the flag, if you think that you've got to set up a super password cracking rig, you're overthinking it. I've talked to people that have set up capture the flag events in the past, and they're like, yeah, then they got to use a rig. And it's just like, it's a bad idea. It's going to make the game not fun for the majority of people that are out there. So that is, cracking passwords on a Windows computer, from a Windows computer system, taking advantage of link local multicast name resolution net BIOS name service to actually crack those passwords. And yeah, you can crack you can crack Landman, you can crack MD5, you can crack NT passwords. It has that support. More importantly, it's super lightweight, and it gives you that flexibility that you can crack something right inside of your Kali instance, which is what we're going to do.
And you were so close to the end there.
No,
the fire went out.
Right? All right, so we've got one more John the Ripper, and for this one, I'm going to use a Kali box. All right, there we go. For this one, we're going to use a Kali box, and we're going to be cracking a zip file, which is one of those things you see in cyber ranges like all of the time. Let me go to my cyber range and pull down my challenge that we're going to be doing. Just give me a second to log in, because everything just went kablooey. So this is Meta CTF and the AASLR Cyber Range that we have set up. And you should be able to see that. All right, there we go. And I can go to problems. And the problem that we're going to be solving here in this cyber range for AASLR is the last great zip file. And it's just a zip archive that has a flag in it. And basically the whole goal is to basically crack the password for this zip file, is ultimately what we are trying to do here. So let's go ahead and let's get started with this on our Kali box. So the first thing I need to do is actually get the zip file. So I'm going to wget the zip file. Now we have the zip file right here. It's flag.zip. If I try to unzip it, it sounds weird without context. It says it's asked for the password. Anytime you have something asked for a password, always try easy passwords, like password. And it didn't like any of those. So what we're going to have to do is we're going to have to extract the password header information out of the zip file, and then we're going to have to crack that. Now, once again, John the Ripper makes this super easy to use. We can use zip to John, and we'll do flag.zip, and I'm going to export it to hash.txt. So there we go. Now I have hash.txt, and there is the actual like encrypted header information. You can see that we have flag.png is what we are after there. Now in your Kali VM, if you download just raw Kali, you have this directory. It's your user share wordlist directory, and in that directory you have the rockyou like word list. And I've already got it extracted. So you may have to actually extract that word list to get it to actually work. So what I want to use is use rockyou. Once again, if you're ever dealing with anything that involves cracking a password, rockyou should be, without question, one of the first word lists that you try. It really isn't all that useful for standard pen testing, but for capture the flag events, like it's one of those go-to word lists that they use all the time. Now, we've extracted that header information that has that password hash in it, and we're going to use John to actually pull that out with the -- word list. So we're going to give it word list option, and we're going to go user. Oh, did I do that wrong? Nope. User, share, and word lists, rockyou.txt. So we're basically feeding a word list into John the Ripper. All right. So we're running John. We're giving it a word list, not a word list. And we're doing equals, saying what is that word list? It's going to be user, share, word lists, rockyou.txt, and then we give it the hash. All right. So now with John the Ripper, like I said, it's going to do some cool things. The first thing that John the Ripper does is going to go straight through the word list with no word mangling. Then it comes back through that exact same word list with character substitution, and then it'll move into brute forcing. So let's see how we do this. Might take for a couple of seconds. There we go. And then John the Ripper was able to quickly get the password for it, which is soldat right there. Now what we're going to do is we're going to use that password. We're going to go ahead and copy that selection. And then we're going to go unzip and then flag.zip. It's going to ask for the password. We're going to paste in the password. Now it inflates what's inside that zip file, which is flag.png. Just going to use Firefox to view it. Takes a couple of seconds. And there is our flag. So like I said, we want one of these to be like nice, short, and sweet. But seriously, John the Ripper is an incredibly powerful password cracking tool by Solar Designer. And just because Hashcat is way faster, especially whenever you're running on a GPU situation, John the Ripper, as far as like a quick little Swiss Army knife, handles a variety of different formats, and it doesn't require a GPU, and it's going to work for most of your CTF challenges that you're going to run into. So that's just kind of a quick little primer on John the Ripper and things that you can do. Serena, Ryan, do we have any questions from people?
Yeah, my question is, who wrote that, first of all?
So interesting story. The person that actually wrote John the Ripper, which can be found at OpenWall, his name is Solar Designer. And Solar Designer, are you talking about the handwritten thing by Roman? I'm pretty sure it was Roman. That actually wrote this. But
continue.
It doesn't look that far off from my handwriting, to be completely honest with you. But John the Ripper was written by Solar Designer, and as near as I can tell, Solar Designer was insane in a brilliant sort of way. John the Ripper is incredibly optimized for a wide variety of different CPU architectures, down to the point where you have like improved garbage collection on like Intel CPUs to speed up the process. Just an incredibly well done tool that was the premier password cracking tool right up until the point that Hashcat just completely took it over with GPU cracking. So there you go. Those two answers in one. What's any other questions?
People said, can I refer to John as John Strand, the John Ripper?
No, please don't. Please don't.
Oh goodness. All right. I don't see any other questions.
Cool. Some additional things about John the Ripper, like whenever you crack passwords, it puts it into a file called john.pot. And I don't even know where it stores this. So let's go with this. I always thought it was funny whenever I was teaching classes. It's like John the Ripper takes your hash, and I would always have, students in the class that would be like, he said hash, man. He said hash. And then I was like, yeah. And then what it does is it stores all of the cracked passwords into a file called john.pot. So literally it takes the hash and puts it into the pot file. And then you'd always have like patchouli hippie students in class that would be all excited because there was all these different pot references that were showing up in my classes. But like right here is, you can see the hash, the type of encryption it is, and then you can see the hash associated with it. And then there's also soldat is the actual cracked password. And then you can also do John, I think it's, let's go John help. I always go right to it, but you can actually have it show the cracked passwords as well. I always just went to the john.pot file, but you can actually have it show the passwords that it has cracked as part of the standard output. So, all right. Any other questions, or are we good to go?
I think we're good.
All right. Awesome. Well, once again, I want to say thank you so much for coming to our address-based layout randomization. As always, it's always going to be random. Serena and I now have a full Active Directory lab. And honestly, as soon as we get it up, I want to get into post-exploitation techniques. If you're down with that, Serena,
Yes.
We should pick a couple and we can go back and forth. Because I think a lot of people think the post-exploitation is nothing but like Bloodhound or Kerberoasting. But on the test, if you want to talk a little bit about the test that you're helping with.
No, because it was just Kerberoasting and Bloodhound. So
I thought you did some NTLM Relay X stuff too.
We did that too.
Yeah. And we might, if we can set it up in the lab, I can show you how you can use Responder with NTLM Relay Hex, where Responder will get an SMB request, and then you can forward it to NTLM Relay X, and then NTLM Relay X will relay the authentication to other systems. It's wild because you can't do, like, if you try to authenticate me with SMB, I can't reflect that directly back to you. Microsoft fixed that back in 2008. They killed SMB authentication reflection. But if you can authenticate to me with domain creds, I can relay that to another computer system and still get it to work. So we might actually show that as well.
I need like that map where it's like the guy pointing and all the strings like
it
different.
Makes sense if you think about it, right?
Yeah, that's exactly what I need.
It's like for years, whenever I was testing, I would have all these testers that, like, I remember Joff's first time, Joff Thayer. He was doing a test for us, and it was like his first test, and he's trying to like find a 0 day in this application with all of this crazy stuff, showing memory and how to jump over the canary to hit the return pointer and all of these different things. And while he's doing that, I'm just sitting there typing, and I'm like, cool, I've got DA. And he's like, how? I found an Excel spreadsheet called passwords.xls, and I pulled it down. And he's like, damn it. You shouldn't make things harder than they need to be. So
yeah.
Cool. All right, Ryan, take us out. Thank you so much, everybody.